Oxygens are there? So then it's -4. So how much is manganese? +4. What is it on the right hand side, Zara? This was homework, ladies and gents. For manganese.
It's
Nee. 2 plus. Why? Where's your notes? But this is what we did the previous day.
Yes.
Listen, you also had to bring me your other book. Where's the valency? This is strange that both of you have written it down exactly the same. No, I think you did it because you WhatsApp me. Right, so what is manganese's valency here?
+2.
Hoekom?
It's -1 times 2.
Yes, chlorine is -1, there's 2 of this is -2, so then manganese must be +2. So what happened, Niakalo, there, from here to here? It added 2 electrons. So is that the oxidation or reduction half reaction? Reduction, because reduction is gain in electrons. Right, so then the other one must obviously be oxidation then. But if you look here, on this side, chlorine has to be -1 because there's hydrogen that is +1, so it's -1. But then we have 2 problems, or a problem, because there's 2 chlorines on the right-hand side. Okay, here we actually use chlorine to get manganese's valency. So here chlorine is -1. So if we consider chlorine from here to here, then nothing happened to chlorine. Okay, so then it's the spectator ion. But if we consider it from chlorine, from this chlorine to this chlorine, then if we look there, chlorine 2, okay, is the diatomic molecule is on its own, so then the valency is 0. So if something is on its own, then its valency is 0. So from here to here, what had to happen? It had to lose an electron. But, there's 2 chlorines here. So it had to lose, so you have to have 2 chlorines here. So how many electrons did it have to lose? It had to lose 2 electrons. Okay. But don't be too afraid of, ma'am, I do not know, how do you get to that? We will get to how it will be actually asked in a test or in an exam. This is still just preparation. Okay, then I'll ask you to write down the reducing agent and the oxidizing agent. Good, Lano. Which one is the reducing agent? Say again? No. But you're in the right reaction. The reducing agent you'll find at the oxidation half reaction. And it's not the thing that you end with, it's always the thing that you start with. Okay? But where did we find this chlorine? There we found the chlorine. So the reducing agent is hydrochloric acid. Okay, the oxidizing agent, what is that, Relay?
Magnesium oxide.
Mooi, magnesium dioxide, because it's the thing that you start with. Where was that? It's that thing. Khali, are you going to pee in your pants? Really? Yeah, then if it's not really, then you stay. Okay, then I'm going to hand out table 4B to you. I'm going to give 4,000. Please add it to yourself. Okay, now, up until now, we have looked at the half reactions and we figured out what goes where. But in a test or in an exam, you do not need to figure it out. It will be given to you. Okay? So at the end of grade 12, but also in grade 11, you will get a data sheet. Okay, now I already took this out. So in your question paper at the end of the trick, one side will be English, the other side will be Afrikaans. Okay? And then in the middle there will be data sheets in the middle that you can take out. I've already taken out half of it, so this one isn't complete. But your data sheet will look like this. Okay? So here you will get the table with constants, then you'll get formulas, and then you'll get periodic table, and then you'll get a table. You'll get a table that says table 4A, and then you'll get a table that says table 4B, and then Afrikaans starts. Okay? So table 4A and 4B. Now, I only use table 4B because I have a cheat that goes with table 4B. Okay, so I only ever use table 4B, never ever table 4A. So you'll see I've copied 4 table 4Bs for you because we're going to work from here a lot. But if you have extra classes somewhere else, or you watch YouTube videos or whatever, and they use table 4A and that works for you, by all means you can use that. Okay, I just never ever use it. So I'm going to work with from table 4B. Okay, so table 4B, if you look at it, you will see that all of the reactions, sorry, I just want to open a table 4B. Okay, you'll see that all of the reactions are written as what type of reactions, Courtney, did you answer? No. Are they written as oxidation or reduction half reactions? They're all written as reduction half reactions because they gain electrons. But as you can see, they are reversible reactions. So you can read them left to right or right to left. Okay? Then you see here on the right hand side, there is this volts. Okay? Yes? Well, you see there's volts. Ignore the volts for now. Those are the things that you're going to work in using grade 12 when you are busy making cells, busy making batteries, what the volts of your batteries will be. Okay, so for in grade 11, we are going to ignore that. We are just looking at, we are just looking at the half reaction. So you see, you do not have to go try to figure them out on your own. It is given. You just need to be able to identify them. Oh, we're busy with this one, this one, this one. In the middle of this table 4B, you can see there is hydrogen there. Hydrogen is printed in bold. Okay, so that's like halfway. You can see the volts is 0 there as well. Now, mostly at the top of hydrogen is metals, and mostly at the bottom of it, it is non-metals. Obviously, there's exceptions, but if I tell you, you must go look for aluminium, then you say, okay, aluminium is a metal. I think it might be at the top of hydrogen. Yes, it is. There's aluminium. Okay, so we're going to use table 4B to get the half reactions. What else did I want to tell you? Then, let's just check. It's a reduction of reactions, metals, non-metals. Oh, and then where you see a H plus, the reaction is acidified. So here you see H plus, plus. You see that quite often. That just means the reaction has been acidified, meaning an acid has been added to the reaction for the reaction to actually take place or to speed up or to whatever. So if you see an H plus, it just means an acid has been added, acidified. Okay, right. We're going to get to table 4b in a moment. Now, when we write these redox reactions, okay, my cheat is that we must write or be able to write a Z. For a half reaction or for a reaction to take place, we are going to make a Z. Okay, we're going to get to the Z in a moment. But for you to be able to identify, to make the Z, you must be able to identify the half reactions. Okay, so when you get a reaction, what you're going to do is you're going to divide the reagents up into their ions. For example, when we had copper sulfate, we said we're going to look for copper ions and we're going to look for the sulfate ions. You remember that? We split it up here when we did this. We split this up into the copper ions and the sulfate ions. So that is what you're going to do. You split them up. But things that are covalently bonded, things that are non-metal with a non-metal, that stays as it is. That you do not split up. But things that are ionically bonded, that you will split up. Okay, but we will practice that. Then we're going to draw a Z. Then we're going to balance the electrons. And then we're going to cancel everything out that we can to write a net reaction. Okay, but I know you don't take anything in that I say. We must do. So let's do. It says there, chlorine is bubbled through potassium iodide. Now you need to know chlorine is a covalently bonded thing. So on your table 4b, you are going to go look for chlorine. Just wait before you do that. Then you need to know that potassium iodide is an ionic bond. How do you know that? Because it is a metal bonded to a non-metal. Okay, so you need to go look for the potassium ion and the iodine ion. Okay, so when we do that, you go to your table 4b and you go look. There is the potassium ion. So you encircle the thing that you start with. Don't encircle potassium. You start it with the potassium ion. Okay, so you look for the potassium ion. Then we have the... Okay, you all found potassium. Okay, then we have the iodine ion. There's the iodine ion. And then here we have the chlorine gas. So I'm going to zoom out for you to see where more or less on table 4b you have found those three things. Alright, now for a reaction to take place spontaneously, for a reaction to just take place, you need to be able to draw a Z like this. Okay, what does that mean? It means the one half reaction must go from this side to that side. So you start on this side and you go to that side. And this half reaction must start on this side and go to that side. Okay, so if I start with these things, I start there, I will go to that way, that way, that way. But ma'am, how can we draw a Z with three things? I thought we only need two things. One of these things will be the spectator ion. One of these things will not change, will not react. Okay? Is there a way that I can, with the help of these three half reactions, draw a Z that would look like that? Tony? From where to where? Which two will I connect? Sevi? The chlorine and what else? So if I connect these two, does that look like the Z that I've drawn here? No, because this arrow points in. The arrow must point out. The iodine. So if I connect these two like that, does it look like my Z? Yes. So there is my Z. So this one here will be the spectator ion. It does not take part in the reaction. Okay, so my Z must look like this. The arrows must point out. So here I can say I start here, arrow point that way, start here, arrow point that way. So here I have my Z. Okay, so here I have a Z. Now I want us to zoom in. Okay, so if I look at this reaction, binne.
Juffrouw,
Ja.
heb Pieter jouw fire extinguisher gevat?
Oeh, ek weet nie. Nee. Okay, so if I look at this half reaction, it goes from iodine ion to iodine 2. And it lost electrons. So what half reaction is that? Oxidation or reduction? Why? Because it lost electrons. If I look at this half reaction, then I see chlorine gained 2 electrons. So this is the reduction half the reaction. And this will always be like that. Okay? You can see I made a note here. The top reaction will always be the oxidation half reaction. And the bottom one will always be the reduction half reaction. Okay. Now, Hope. In the alphabet, which one comes first? O or R? A, B, C, D, E, F, G, H. Please go through the alphabet. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R. Okay. Alright, it's fine. So, O comes before R in the alphabet. So, oxidation is the top one, reduction is the bottom one, always. Okay, or you can just look at the electrons. Right, so now we have our oxidation, reduction, half reaction. So from your table 4b, you copy, listen carefully, you copy those half reactions exactly like it is. Okay, but the oxidation half reaction is from right to left. So we are going to write it, we're going to write it down from this side to that side. So you're going to start with 2 iodine ions gives you iodine plus 2 electrons. So you can see you copy it exactly from table 4b. The half reaction is given to you. Okay? Yes? But please be careful. You do not write both arrows. You only write one arrow. We're going in this direction now. Maybe in another reaction we go the other way. But in this reaction we go this way. Okay, reduction, half reaction, you also copy exactly like it is on table 4b. Okay, so for you to be able to copy this reaction exactly like it is, you get 2 marks. 1, 2. Ne? Easiest chapter in your life. 2 marks for copying something from table 4b. Now, to write the redox reaction or to write the net reaction, you first have to balance the electrons. Here we have 2 electrons, here we have 2 electrons. Do they cancel out? Yes, they do. Alright, and now we're going to write the net reaction. So we're going to say, alright, this is on the left hand side, the arrow, this is on the right hand side, blah, 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 blah. So you're going to write 2 iodine ions plus chlorine gives you iodine plus 2 chlorine ions. Easy peasy? Yes. Right, let's go look at the next one. Sulfur dioxide is bubbled through potassium dichromate. Rory, what color is potassium dichromate? Options. Is it purple or orange? Wait, orange. Okay. Now, sulfur dioxide, you must know, is a covalently bonded substance. How do you know that? Well, first of all, it's a gas. Secondly, it's a non-metal bonded to a non-metal. So you're going to look for sulfur dioxide on table 4B. Then, potassium dichromate is a ionically bonded substance. How do you know that? Because it's an orange crystal. It's a salt. So you're going to look for the potassium ions and you're going to look for the dichromate ion. Okay, so I want you to please go to table 4B. Okay, now wait. Okay, when you go to table 4B now, take your highlighter and we're going to highlight it now because we're going to use the same things often. Okay, so go to table 4B and go look for those things.
Must we use the same table or the other table?
You can use the same table or another table, your choice. Oh, nothing else here. Okay, I'm waiting for a question, but it's not coming. Ma'am, I found potassium. We've just used it, so there's potassium. Okay. Then I think I found dichromate. Here's Oopsie. Here is dichromate. Yes? But sulfur dioxide, there's two of them. There's one and there is one. Which one do I use? Can you see that this one said it is acidified? And this one does not say it's acidified. It's just there's water present. Okay, did I tell you that the whatever is acidified? No. So if I didn't tell you it's acidified, then it's not this one that is acidified. It's this one. But ma'am, where's the water? The water is present in this thing that was, I must actually have said this is a solution. Solution, which means water present. Water present. Yeah. AQ. Okay, so that is how you know this one and this one and this one. Your question in a test or exam will not be this difficult. Okay. Alright, so this reaction must go this way, this one will go this way, this one will go this way. Where can you draw your Z, Sia? With which two? The chromate and the sulfur dioxide, there I can draw my Z. So again, potassium is the spectator ion. Okay, so there I have my Z. Now, I want you to go write down the two half reactions like it is given to you. And you write down everything. That plus that gives you that and then that. This plus this gives you this. So go write down everything. Remember the top one is the oxidation half reaction. Okay, please check yours with mine. Have you copied everything correctly? Have you copied it in the correct order? Meaning you haven't swapped these two things around. Is there only one arrow? You didn't copy both arrows, only one arrow. Yes.
You use a mark if you don't write it exactly.
Or like did you change that for round, for example? Yeah, that's fine. Alright. What is the next thing that we must do, Khali? Balance what? Say again? But what must we balance? Because there's lots of things there. The electrons. Here we have 2 electrons. Here we have 6 electrons. Let's see, how are we going to balance them? These are 6. These are 2. Shh! Don't listen to him. What? Yes, you are. No. You're going, because it will be difficult to divide 1 by something, then you sit with a fraction or whatever. Yes. Audience? No! Multiply by 3. You're going to multiply the top one by 3. So do that with another color or with a pencil. You're going to say, I'm going to multiply this whole thing by 3. You're going to multiply straight through with 3. This becomes 3. This becomes 6. This becomes 3. This becomes 12. This becomes 6. So you have to multiply straight through by 3. No. This is not a fraction. Because if you multiply the bottom by 1 with 3, then the electrons do not cancel out. Khali. Simple. Then what's the next thing that we do? Cancel out the what? Yes. So we see here 6 electrons, sharp. Cancel out, cancel out. Is there anything else that can cancel out or not? Yes. Here we have 12 hydrogen ions. Here we have 14 hydrogen ions. They're not going to cancel out completely, but they are going to become less. So if I cancel out these 12, then here I have 2 left. Anything else, Zara? Yes. Here I have 6 waters. Here I have 7 waters. So this is going to be cancelled out completely, and here I'm going to have 1 water left. Yes. Who's marrying me? What? Yes, water molecules, yes. Alright, so there's nothing else I can cancel out. Now I can write my redox reaction. 3 sulfur dioxides plus the chromate ion plus 2 hydrogen ions give you 3 sulfate ions plus 2 chrome ions plus a water. Okay. Let's look at the next one. Bromine, the diatomic molecule. So, diatomic molecule, covalently bonded, stays as it is. It's bubbled through potassium chloride or chloride. Okay, so we're going to look for those three things on table 4B. Oopsie. You found them? Right. Is there a way that we can draw our Z? Like this will not work. This is not a Z. It's a S. This will not work. It's also an S. So there's no way that we can draw a Z. So because there's no way that we can draw a Z, it means this reaction does not take place. Okay, so now your homework, classwork, and if you don't finish homework, is page 24. Page 24. Okay, so you start with that. Yes, the whole page. Okay, but I think some of you might struggle with these compounds, so I'll help you with the compounds. Here we have hydrogen sulfide, it's H2S. Iron 3 chloride means it's ion and 3 chlorines. Sulfur dioxide, potassium permanganate. Potassium permanganate like that. Again, hydrogen sulfide. Again, potassium dichromate. And then they tell you it's acidified, the potassium dichromate. It's acidified. Aluminium with lead nitrate. And iron with chlorine gas. But now you know them.
Okay, now we know them.
But most of the time they'll give you a clue or a hint or a help or whatever. Okay, go for it. Just want to help you with the last one. It's going to go from iron to iron 3 plus because there's 3 ions. So the last one is going to be iron to iron 3 plus. That there's a 3 plus. Right, go, go, go.